Welcome to the Deep Dive. I am your host, and today we are getting into something that is, honestly, fundamentally changing how you interact with every single device you own.
Glad to be here. I'm your resident expert for today, and yeah, we are mapping out the UX revolution of 2026.
Specifically, this massive shift toward designing for what we're calling intentional systems. Because, we've spent decades in this highly transactional relationship with our screens.
Oh, absolutely.
For years, all of your complex human intentions, your urgency, your frustration, your deep focus, all of that has been compressed into these really rigid clicks and static form fields.
Which is incredibly limiting when you think about it, but that era of forcing humans to speak computer is officially ending.
Thank goodness.
Right, it is a massive paradigm shift. We are moving from static, unchanging interfaces to adaptive, probabilistic systems. We are finally at a point where the digital environment actually treats the user as a complex, contextual human being.
And that changes who is actually building these things.
Right. Completely. The traditional role of the layout designer, the person who spends their days deciding exactly where the blue button goes on the specific screen, that role is evolving into a design orchestrator.
A design orchestrator. I like that.
Yeah, they aren't drawing screens anymore. They are creating the logic, the variables, and the boundaries for systems that think and adapt in real time.
Okay, let's unpack this because we should start with this idea of generative user interfaces, or GenUI.
The death of the fixed screen.
Right. Anyone who follows tech knows how standard app design works. It's deterministic. A designer anticipates a scenario, maps out the user journey, and then draws a fixed screen for it.
But this new probabilistic design model flips that entirely on its head.
Because the screen isn't drawn in advance anymore.
Exactly. In a probabilistic model, the interface doesn't actually exist until the moment you need it. The design orchestrator defines a massive set of constraints rather than drawing a layout.
So they're building the rules, not the final picture.
Precisely. We're talking about defining design tokens. These are basically raw variables like specific hex codes for brand colors or strict typographic scales. They set tone rules, accessibility baselines, and decision hierarchies.
So the AI uses those rules as building blocks.
Yes. By establishing those foundational rules, designers empower AI systems to contextually assemble the interface on the fly. So when you open an app, you are looking at an interface generated a millisecond ago, optimized specifically for your current context.
Let's ground this for the listener with that brilliant airport analogy from our research. It really clicked for me.
Oh, it's a great example.
So imagine you are a traveler and you are running incredibly late for a flight. You're sprinting through Terminal B, you pull out your phone, and the system starts reading signals.
It sees your location, your erratic interaction tempo.
Yeah, the fact that you were just frantically scrolling.
And in the old deterministic model, you'd open your airline app and it would just show you the default home screen.
Right, maybe it's a promotional dashboard asking if you want to sign up for their new Platinum credit card. The app doesn't know you're stressed, it just knows you opened it.
But with GenUI, the system recognizes that urgency. It dynamically reads the situation.
So it doesn't show you the ad. Instead, the AI pulls from those design tokens we talked about and generates a high-contrast, stripped-down navigation path pointing you straight to your gate.
What's fascinating here is the sheer level of responsibility this places on the constraints.
Because things could go wrong.
Oh, very quickly. GenUI is wildly powerful, but if those predefined rules are weak, the whole thing falls apart. You run right into interface drift.
Wait, let me stop you there. If the AI is constantly generating layouts on the fly, doesn't an app just lose its identity? I mean, how do you even know you're still using the same airline app if it looks different every time you open it based on your mood?
That is the exact friction point of interface drift. If the AI doesn't have strict guardrails, it will prioritize extreme efficiency over brand coherence. And suddenly, every app just looks like a generic wireframe.
Which is terrible for branding.
It is. Or worse, you suffer a dangerous loss of user agency due to over-automation.
Meaning the system thinks it's helping, but it's actually getting in the way.
Exactly. If the system incorrectly assumes you are in a rush and hides vital flight change options because it thinks you don't have time to look at them, it takes control away from you. This is why the design orchestrator role is so critical.
You need those boundaries.
We need rigorous systems thinking to prevent these hyper-smart interfaces from boxing users into corners.
So we are breaking away from fixed screens, but we are also breaking out of the 2D plane entirely. The screen is no longer the primary container for our digital lives.
Which brings us to spatial UX.
Right, with devices like the Apple Vision Pro transitioning from clunky tech demos to actual daily workflows, we are heavily utilizing the Z-axis now.
The depth.
Yeah. Depth, proximity, and physical anchoring are the new tools for information hierarchy. In the past, to show importance, you made a font bolder or a button brighter. Now you use distance and scale.
You literally place a digital object closer to someone in their physical space to command attention.
Which is wild.
Huh.
But you noted in your research that this requires an immense amount of spatial discipline.
It really does. You can't just throw digital objects around a room haphazardly. You have to establish fixed anchor points.
So things don't just float around in midair.
Right. If you are moving data arrays around a user's physical office, they need to remain anchored to real-world geometry, like the edge of a desk. If they don't, you get vestibular mismatch and severe disorientation.
Because nobody wants to get motion sickness from checking their email.
Or suffer severe cognitive fatigue. That's why another core principle is severely limited motion. You cannot have peripheral menus constantly floating around someone's head while they're trying to focus.
That sounds exhausting.
It is. Furthermore, the system must utilize real-world lighting and shadows. And this isn't just to make it look cool or cinematic.
Yeah.
It's a fundamental requirement for physical trust. Your brain needs the digital object to cast a shadow on your physical desk so it can subconsciously process its mass and distance.
I can see how that's incredibly useful for high data density tasks, like architecture simulations or complex financial modeling. But I imagine if I just want to set a timer or check a text message, navigating a whole 3D environment is total overkill.
It is entirely wasteful for simple tasks. A major pitfall right now in design is the assumption that the future means everything in 3D.
Right.
It doesn't. Spatial UX is about choosing dimensionality intentionally. Forcing a user to physically reach out and grab a 3D toggle switch just to turn on an alarm is a massive regression in usability.
Okay, but if spatial UX is mostly reserved for those complex 3D workflows, how are we interacting with the system the rest of the time? We aren't still relying on a mouse and keyboard, right?
No, which brings us to multimodal UX.
Because historically, input channels were completely siloed. You typed or you clicked or you spoke to a smart speaker. They didn't talk to each other.
Right. But multimodal fuses gaze, gesture, voice, and haptics into one unified interpretation of human intent.
And to process that fusion, we rely on what the sources call the signal fusion stack.
Yes. It's a 4-layer architecture. First is detection, which is just the raw capture of your eye movement or hand gesture. Second is intent disambiguation.
Big word.
Yes, intent disambiguation. Third is confirmation, giving you a subtle haptic or visual cue that the system registered your action. And finally, response generation.
Let's pause on step 2, that intent disambiguation. How does an AI actually filter out the noise? How does it know if a hand movement was a command to close a window or if you were just, swatting a fly away from your face?
That right there is the hardest challenge in modern computing. Intent disambiguation requires the system to cross-reference multiple data streams instantly.
So it's looking at everything at once.
Exactly. If your hand sorted quickly, but your gaze was focused on a coffee cup across the room and not the digital interface, the system has to infer that the gesture wasn't meant for it.
That sounds like an absolute nightmare to engineer.
It is, and it fundamentally changes the nature of the work. This is no longer a traditional user interface problem. It is an inference accuracy problem. The system isn't waiting for a definitive binary click anymore.
It's just guessing based on probabilities.
It is constantly calculating the probability of your physical movements. And when it achieves high accuracy, it's magical. It dramatically increases interaction speed, and it offers a massive leap forward for accessibility, especially for users with motor impairments.
But the technical overhead to ensure the system doesn't accidentally delete a file because you sneezed is monumental.
Absolutely monumental.
Here's where it gets really interesting. Because if the system is constantly inferring what you want, we actually cross the threshold into zero UI.
Yes, zero UI.
Now, to be clear for you listening, zero UI does not mean interfaces vanish and you just telepathically communicate with the ether. It's about shifting the cognitive heavy lifting. Instead of the human initiating every single action, the system anticipates needs based on context, habits, and inferred states.
And crucially, we have to point out, this is not raw biometric surveillance.
Right. It's not tracking your pupil dilation to sell you targeted ads.
No, it's analyzing your usage rhythms.
Yeah.
Like knowing you always pull up specific project files when you sit at your desk at 9 a.m. so it predictively executes those micro-decisions for you.
This raises an important question, though. What happens the moment that ambient system guesses wrong?
That is where we need the trust architecture. It's the safety net. Because if a zero UI system predicts your intent incorrectly and takes an action you didn't ask for, it feels deeply intrusive.
It violates human autonomy.
Exactly. If the
Yeah.
system constantly dims your lights and boots up your media player because it assumes you want to watch a movie, but you actually just want to read a book in silence, the technology quickly goes from being helpful to being an antagonist.
So how do you build a trust architecture that prevents the system from feeling like an overstepping robot?
You have to engineer transparent override mechanisms. The user must be able to instantly correct the system without fighting it.
Like a really easy undo button.
Yes, highly visible undo paths. And most importantly, you need predictability indicators. The system must be capable of explaining its logic.
Showing its work, basically.
Right. If it takes an automated action, there needs to be a subtle way for the user to see why that action was taken, along with an escalation ladder that lets them seamlessly transition from full automation back down to complete manual control.
I love that concept of trust, and it ties directly into how we manage our mental energy, which brings us to a massive shift in the industry, neuro-inclusive design.
This is a huge passion of mine.
Because accessibility isn't just about color contrast ratios or screen readers anymore. It is heavily focused on cognitive energy. It acknowledges that conditions like ADHD, anxiety, and executive fatigue aren't just edge cases. They are universal human states.
We all experience cognitive depletion.
Absolutely.
And that is the driving force behind cognitive UX. We are seeing a rigorous integration of cognitive load audits. Design teams literally measure the working memory required to complete a digital task.
That is fascinating. How do they reduce that load once they measure it?
They rely heavily on progressive disclosure. It acts like scaffolding. Instead of showing you the entire complex dashboard all at once, the system only reveals the exact tools you need for the immediate next step.
Keeping the focus tight.
Right. They prioritize highly stable navigation patterns and build extremely error-tolerant systems with always visible recovery paths. The whole point is that the fear of making a mistake is removed from the user experience entirely.
There is a brilliant principle from the sources driving this. Clarity is not minimalism. It is cognitive safety. I feel like that completely reframes the last decade of design trends.
It really does. For years, designers stripped away buttons, borders, and labels to make software look clean and minimal.
Just hiding everything in hamburger menus.
Exactly. But if a user has to guess where a critical function is hidden, that isn't clean. It's anxiety-inducing. True clarity provides a feeling of safety and predictability.
And there's a business case for this, right?
A massive one. The data shows that in large enterprise environments where thousands of employees use complex software daily, designing for cognitive safety heavily mitigates operational risk. It drastically reduces user errors, speeds up decision-making, and significantly lowers IT support overhead.
So when you design for cognitive ease, you protect the bottom line while protecting the user's mental bandwidth.
It's a win-win.
And speaking of bandwidth, we have to look at the physical impact of all this technology. This brings us to a really fascinating area, sustainable UX.
People forget about this part.
We do. We often treat digital interactions like they are completely invisible. But every swipe, every generated layout, and every AI inference has a physical energy cost. It requires server farms to process data, networks to transmit it, and local hardware to render it. The digital world is actually a massive contributor to global carbon emissions.
Which is why digital weight management has become a core competency for the modern designer. They aren't just managing pixels anymore, they are managing energy consumption.
How does that look in practice?
It means implementing extreme asset compression so dynamic interfaces load lighter. It means designing systems that make fewer API calls. Every single time an app pings a server for data, it spins up resources and burns electricity.
So by intentionally reducing those API calls at scale, you save actual megawatts of power.
Precisely.
So if a poorly designed workflow takes 10 clicks and 3-page loads to complete, I'm keeping my device active longer, and I'm forcing the cloud infrastructure to work harder. But if predictive efficiency gets me to my goal in 2 clicks, I've saved my own time and directly reduced the energy cost of that task.
And that is the brilliance of predictive efficiency. It aligns user experience directly with environmental sustainability. They are no longer competing interests. Performance has officially moved from being a purely technical metric that engineers worry about to being a fundamental ethical metric for design teams.
Reducing infrastructure strain is now recognized as a core responsibility of creating digital products. That is huge.
It is a total shift in mindset.
So what does this all mean? We've covered incredible ground today. We've explored interfaces that generate themselves on the fly, three-dimensional spatial workflows, multimodal environments that fuse voice and gesture, and ambient systems that anticipate our needs to preserve our cognitive energy.
It's a lot to take in.
It is. But if we synthesize all of this for you listening, the grand takeaway is that we are moving entirely away from input mechanics. We are no longer designing for where the finger taps. We are moving entirely toward intent modeling. We are building systems that attempt to understand you deeply before they ever respond to you.
If we connect this to the bigger picture, it completely redefines what it means to build technology. The creator of 2026 is no longer a layout specialist. They are a constraint architect. They are a behavioral modeler.
A trust engineer.
Above all else, yes, a trust engineer. They have to audit for human intent, engineer graceful recovery paths, and rigorously model your cognitive energy. It's a highly optimistic outlook, really. It proves that this era isn't the moment AI replaced human designers. Rather, it's the moment designers evolved to handle the profound complexity of human intent.
It's an incredible evolution to witness. We are stepping into a world where our technology molds itself around our minds, actively working to remove every barrier, every point of confusion, and every wasted ounce of energy.
It's an exciting time.
It really is. But as we wrap up this deep dive, I want to leave you with a final thought to mull over. Something to explore on your own that builds on all this hyper-predictive, frictionless technology. If our ambient systems become perfectly calibrated to anticipate our needs, clear our obstacles, and eliminate all friction from our daily tasks, what happens to our innate human resilience?
Wow.
Right. When you no longer have to navigate the friction of making micro-decisions all day, do you risk losing your capacity to handle the unexpected, messy, and unoptimized friction of the real, physical world?
That is definitely something to think about.
It really is. Think about it. Thanks for joining us on this deep dive. We'll catch you next time.